Hello and welcome to a special session of Unity's live training. Today we are going to have an introduction to and an overview of Unity's new UI tools. Finally, it's here, and actually it looks really good. And I've been playing with it. I've been using it during the beta, and it works well. It works really fast. It works efficiently. It's incredibly versatile and incredibly useful. One of the things about the UI toolset is that it's a 2D toolset. We instantiate it in our scene, unlike on GUI, which many people may be used to, which is an immediate mode UI. And that immediate mode UI was written in code and is called several times a frame during the on GUI UI loop. It's a strong workhorse. It will be the just so because some people will ask, it's going to be still be the backbone of the UI in editor scripts and the way that the editor is built, because it makes a lot of sense to have an immediate mode UI running the editor itself. But it doesn't make a lot of sense in some cases when we're doing games. I still think I still think there are many good points on GUI, but here we have our retained UI that we've got with our new UI tools. It is 2D. That doesn't mean we can't use the UI in 3D space. If we take a look at our little capsule guy saying hello, and we take a look at it in 3D space, we can see that this is a little 3D UI. Now, if we turn on our canvas overlay here, we can also see that we have overlay canvases as well that work on top of everything. They lay on top of the game in the game view. And then we also have our screen space cameras, and they are kind of a middle of both worlds. They are in 3D. You can use a perspective camera. In this case, we're using this perspective camera here to render this particular UI element, but it's not necessarily stuck in the game world right there with our characters. It's in another space on another layer. So since we are using a 2D tool set, we're extending and repurposing a lot of the tools that were created for the 2D framework that we've recently come out with. And as we can see, we've got a little new tool up here called the Rect tool. And with the Rect tool, we can do some fun things. We can stretch and scale, we can rotate, and we can move. All using the same single tool when we're in 2D mode and we're dealing with our 2D sprite elements. So speaking of staying in the 2D space, most of our elements are going to be 2D elements, which means we're going to be using, let's go ahead and take a look at some examples here. We're going to be using sprites. So we have all of the same import pipeline that we do when we're dealing with sprites for our 2D system. We're going to import that sprite type, and we can edit those sprites in the sprite editor. I'm not going to go into great detail because I think there is resources on our website in the Learn section for looking at how to use the sprite editor and the sprite type. But it's important to know that most of the graphics that we're going to be using today in our UIs are going to be sprites, and they're going to be imported using the 2D sprite pipeline. And one of the things, just while we were there, let's go ahead and take a look at some of these other sprites. If we take a look at the 9-slice sprite, the reason it's called 9-slice is you're dividing your sprite up into 9 segments. And the corners don't scale, and the edges only scale in one direction. This allows us to resize this graphic without distortion of the edges. The backbone of the UI system is the canvas. And I'm going to go ahead and pop out, double click that so that we can focus in on the canvas there. Now the canvas, all UI elements must be the child of the canvas. Canvas is the root parent that all of our UI elements will exist in. And we can see that you can have multiple canvases in the same scene. We've got 2 canvases here, one for our overlay and one for our screen space camera. Let me just go ahead and bring on the contents. Remember, that's our overlay, and there's our screen space. So I'm just going to quickly move this the content of this panel. I'll explain what I'm doing in just a second. We'll just move that over there. And then I'm going to change that rotation there so it's in the other direction. And then we've got our canvas here that's in world space. We've got 3 completely different types of canvases and 3 different canvases. But the point I'm trying to make here is that every one of our UI elements is a child of that canvas. So we've got our text and speech bubble as the child of the canvas in world space. We have our panel as part of our screen space camera, and then we have this little mock audio menu as a parent of this overlay canvas. The next sort of heavy workhorse in our UI framework is the Rect transform. Now, if we take a look at a normal game object, we can see that we've got our transform, which includes position, rotation, and scale. But when we take a look at any element, we can see that there is the Rect transform in there, and that's slightly different. The Rect transform is a replacement transform for all UI elements that are the children of a canvas. Whereas in 3D space, that transform has the position, the rotation, and the scale of our object. Let's go ahead and make a cube for that. So let's create a 3D object. Let's create a cube. I'm going to reset that back to origin. Let's bring that up by a unit, and then let's frame select it in on that. So there's our cube. And so we've got our transform, and it gives us our position, and it also gives us, and we have to start changing our tools for this, and our rotation, and then our scale of our 3D object. But what we have for the Rect transform, our Rect transforms, they keep track of a rect or a rectangle, and it's going to be its position in the lower left. It's going to be its position X, position Y, and its width and its height. So we've got there the position X and the position Y, and then the width and the height, defining that rectangle. And there is a position in the Z, and we do have rotation and scale, so we can go ahead and position those in 3D view. But also, part of the power of these Rect transforms is we also have anchors, and I'll go into that in a little bit more into detail. All measurements in the Rect transform are based around the pivot. Let me go ahead and move to our UI tool. So let me go ahead and move to the Rect tool, and with the Rect tool we can go ahead and let me just zoom in there. Our pivot in this case is up here in the corner, so there's our pivot point. And we can move that around. I've just moved the pivot to the center, and you can see that it's got little snapping handles there. So all of the measurements that we have are all based around the pivot point here in this Rect. And we can see that as we move this around, the pivot location is changing, but also our position X and Y are changing because that position is relative to where that pivot is. And so when the pivot is in the upper corner where it was snapped before, we are measuring its location 25 pixels over and 25 pixels down from that pivot to the anchor point. As we've seen that all UI elements need to be the child of a canvas, all UI elements have Rect transforms, and all Rect transforms are anchored to their parents if their parent has a Rect transform. Now, it's possible that you could have a member of the family under a canvas that doesn't have a Rect transform. You can make a game object without a Rect transform and attach it to the canvas. It's possible, it's just not something that you'd probably want to do. So in nearly all cases, all of the children of a canvas will have a Rect transform, and the canvas has a Rect transform. So all of the UI elements in a canvas family are going to be anchored to and attached to their parent. And we do that with that anchor point. Now, these anchor points are actually not one, but 4 anchor points. And when they're together, as we see here, we're anchoring to a single point on the parent. In this case, this panel is anchored to the corner of the parent. And the distance, so our width and height of our UI element is 400 by 300. And the position is how far away we are from our anchor. We can see we can grab it and move that. And so we put that back. And so we can see that that's where we are. If we were to move the pivot point, we can see that we have a different position, but the panel has stayed in the same place because the pivot's moved and we're now farther away from our anchor. So we have our anchor. The relationship of the anchor from the pivot to the anchors is a fixed value. So if the parent changes, and we're previewing this, we can see that the distance from the pivot to the anchors is fixed. But if we split them up, we can still have, we're still fixed. The anchors to the pivot is still a fixed value. But the anchors to the parent, in this case to the canvas itself, because the panel is one down, the panel is anchored directly to the canvas. It is relative. It's relative to the size of the canvas. So now, if we move that parent, we can see that the size of the panel is moving and resizing relative to the size of the parent. Now, just so you know what I'm doing, anytime we have an object that is anchored to a parent, you can, when you're holding on to the game object, you can take the parent's Rect and resize it, and you can see that little preview has popped up. And so we're previewing what happens if it changes. And that's true of any of the elements. So if we can drill down and we can grab that menu text, and the menu text is anchored. We can see the anchor up here, anchored in the upper left. And I can now move the panels rect, and we can see that's not going to do anything because it's not changing relative to the anchor. I can move the anchor, and now we can see what's moving there with that anchor. And if I was to match those to the corners, we can see that that's now going to move relative to the size of that parent rect. So I'm going to undo that, undo these terrible changes that I'm doing to this rather nice mock menu that's been given to me. Anchors are a powerful tool. They're not necessarily meant for making your UI so they fit on all devices and they fit at all aspect ratios, though this is part of that solution. The primary use for it in this case is that if a UI were to change, we can see down here, where if someone was to change the scaling of their let me go ahead and reset that layout as well. Boom. There we go. And I'm going to go back into free aspect mode. And you can see that that's one of the good reasons for using this. You can see as I change my aspect ratio, we can see that the UI is adjusting automatically to these changes. And so I'm going to go back into that free aspect. I'm not going to go into terrible amounts of detail into each one of these parts of the UI because you'll discover as you see this, that also on the website in the Learn section, we have uploaded a number of new lessons for the UI, for the new UI, and they'll go into these in detail. So you'll find details on the canvas, you're going to find details on the scroll bar and details on the slider, details on Rect Transform. So this is just purely an overview. So if you want to know a lot more detail about the anchors, go ahead and look at the Learn site, look at the new lessons that we have there where I go into detail about how those anchors work. I just want to quickly show you what the UI is looking like, what these new UI tools are looking like, and what they do. So let's go ahead and take a look at this audio menu. I'm going to go ahead and hit play mode just so we can see some of these things working. They're not hooked up to anything right now, but you can see that we've got a slider here with a slider handle, and this goes ahead and sets a value. We've got toggles here, and we can change these toggles into a toggle group. Right now we can toggle any one of these on and off, and then buttons, of course, they click. So we've got our hover, we've got our click, and we've got our release, and so these are states. A number of different UI elements use transition states, and they share transition states. I go into them in a little bit more detail in the lessons, but let's take a look at these now. Let's take a look at this panel, and let's take a look at the, let's say, the back button. And if we take a look at the back button, we can see, as we drop that down, we've got our 9 sliced sprite, so we can go ahead and we can adjust that. Ooh, no, I don't want the text. Come back here, back button. We can adjust that sprite, and we can see that the because of the slicing, that the middle is stretching, the center part is stretching, but the edges stay nice and crisp because of the slicing that we have with that sprite. This button does not have a text element written into the image. The button is clean. That means we can repurpose it. Let's see, where's the accept button? Right there. And you can see that it's the same button that's being used twice, and we have a text element that's associated with it, and that text element is going to go on top. And when you create an automatic text button from the create menu, that text element is included. If you were to have a graphic built in that had the contents of that button, either in text or in an image that was painted into that button, and it was a special use, you could go ahead and simply remove that text game object, and it won't break anything. So that text object is optional. So the button element itself has an image, and that's the plain image that we have there, which requires a canvas renderer, but that's created automatically when you add the image script. And then there's the button script that keeps track of the functionality. Interactable, if we have interactable false, you can see that it's set to disabled mode, and it's a disabled sprite. It's a disabled mode. It means that it won't accept any input. Then there are a bunch of different transitions we can choose. We can choose tint color. When we've got tint color going on, we just simply tint the color of the original graphic. There's only one graphic here, and we go ahead and we change that tint color. If we were to change it to something wild, Oops, let's go ahead and try that again. Change it to something wild. There we go. Wild color. You can see that it's fighting the original color of the graphic, but you can go ahead and do some, do some wild things here. And it's just simply changing the tint on that sprite. It should go away when I exit play mode. Yes. And then there's sprite swap, and what sprite swap is doing is using a bunch of different images. So we've got 3 different images here. We've got the GUI button disabled, the GUI button highlighted, and the GUI button pressed. And the sprite swap transition is simply transitioning the graphic when the events are detected by the event system. When the mouse hovers over the button, the mouse presses the button, or the mouse releases the button. There's animation. An animation will allow a fully animated button using Unity's animation system. I go into that in a little bit more detail in the lesson, so I would strongly encourage you to take a look at the transitions lesson or the button lesson, both of which contain the information about how to use the animation. But if you have an animator component, you can use Unity's mechanism state machine to be able to drive the animation, and you can set up states for all of the parameters that you have available for this button. You can change its size, you can change its color, you can change its texture, and you can animate these over time. So what if we want to have this button do something? Unity's UI framework works closely with a new powerful event system. The event system is created automatically if the canvas is created automatically when we use the create menu to create our UI elements. And that event system works for both standalone input and touch input, and that input system works with our UI elements to detect and process input and send input events. So we can see that on the button is a built-in on-click list. We can add functions to be called. This is a function list, and all of the functions on this list will get called when Unity processes a click on that button, and a click being where there is a press and a release on that same button. If you were to press on the button and then move off and release off the button, an on-click event would not be processed. So what you do with this is you have a game object. You can associate a game object with the object field. In this case, let's grab the main camera. And then we can pick any function. So the first list is all of the components that are on that game object. And if we had written a custom script, we would see that. So let's go ahead and pick, say, the camera. And then let's go ahead and check is orthographic. And so what we're going to do here is on the click of this button, on the back button, we're going to set our main camera to being orthographic. And so this is the Boolean choice. What are we going to send? We're going to send is orthographic true. So let's go ahead and save, and let's go ahead and hit play. And now when we go ahead and hit the back button, we can see that our camera immediately goes to becoming is orthographic. Now, we could have fun. We could go ahead and make the accept button. I'm just repurposing these buttons as we talk on the fly. And we can say that let's grab that main camera, and let's say the camera is orthographic. Oh, it probably should be orthographic, not is orthographic, is false. So let's go ahead and change that back. I should probably have not said camera is orthographic, but camera orthographic, that one. So let's hit save. Now, when we hit play, this button makes it orthographic, and that button brings it back to perspective. So you can see how quickly we hook that up. And these are functions, public functions that are exposed on the game objects themselves, on the built-in Unity game objects themselves as the main camera. But we could write our custom scripts as well that could be accessed just as quickly. To remove a function from the function list, you can either temporarily disable it by clicking the enabled button here. We can disable that, or you can select the whole row and you can go ahead and hit the minus button, and that will delete that function in whatever state it is from that list. So let's say we wanted to hook up our own custom script. What I'm seeing here is I've got this nice little slider here for our sound effects and our music. And I've got a visual representation, but what if I wanted, say, a numerical representation of this? So what would I do if we want to go ahead and hook up this slider, this SFX slider, and we want to see the value here next to it? The first thing I'm going to do is grab that SFX text, and I'm going to duplicate it, and it puts it here at the bottom of the list, which we'll talk about in a moment. And then I'm going to change this to SFX value, just so it's a different name. And then I'm going to go ahead and grab this, change this to XX, so that we're going to put in our values so we know what they are, and little placeholders for our values. And let's go ahead and change that and move that over. And then I'm going to make sure that that's centered. So I've got this new value. This is where I'm going to print the value of this slider as it moves back and forth. So on this text element, I'm going to go ahead and create a new script, and that's going to be called update value. So update value. And then let's go ahead and edit that in monodevelop and get rid of all of that code. The first thing I want to do if I'm going to go ahead and write for the new UI is I want to be using the Unity engine .ui namespace. So the first thing we need to have is a reference to our text. So let's make that a public text, and we can see that now that we're using Unity engine.ui that we've got our text there in the namespace, and then let's just call that text. And then to call a function, we can call any eligible function from our event list on our UI element. To be an eligible function, the function needs to be public, the return type needs to be void, and then we can have some sort of fancy name like update text. How about that? And then we need to have one or no parameters in our function. Now, in our case, we're going to want a parameter. We're going to have a float parameter. The parameters can be float, can be int, can be string, can be bool, or it can be Unity object. I think those are most of the list. If you check my lessons, I have them definitively listed there. These are the ones that I remember. So float, int, string, bool, or Unity object. Now, Unity object is a bit deceptive because so many things derive from object. Game object, component, mono behavior. So nearly everything can be passed through in that object as an object reference. So this is going to be far more powerful than it seems at first glance. So we've got our update text, and so let's put in the parameter. Let's put in float f. Let's just call it f. I'm not feeling very creative tonight. And then let's just say that our text.text is going to be equal to f.toString. So let's save that and come back to Unity. And we can see that we've got our text there. So let's go ahead and drag that reference nice and easy. So let's save that. Oh, we're in play mode. We're in play mode. It's there. So let's save that. Let's go ahead and hit play. And then we can see that that text is being updated. We could control the number of digits. Right now it's just fitting as many as they can. So in certain cases we'll see a little tag end of that other that second digit. But we can see that we've just quickly attached a script. We've got an event that's going on that's being handled internally by Unity. It's updating that value. So we can attach any script that we want. Now the other way we could have done this is we also could have taken, if it wasn't a float, we're going to use a float in this particular case. We could have sent it through with like this, but let's also get a reference to our slider. Let's just call it slider. And if we had no parameters here, we could then set something like every time this is updated, it's going to, so every time the value of the slider is updated, it's going to still call this parameterless function. And then we could say our text.text is equal to the slider.value to string. So, there are various different ways that we can do this. So normally you'd want to send things through the dynamic float if it's available, but this is more of an example of what to do if for some reason the value or the object that you're trying to send is not available as a dynamic one. You could do something like this. Let's go ahead and populate that slider reference. And then if we look back at the SFX slider, we can see that we've changed the signature to that function. So we now are missing the function because technically that function doesn't exist now that we've changed the signature. So we can go ahead and hook it up again. And there's update text. Note that since nothing is taking a float parameter, that there is no dynamic float list, no dynamic value list. So we're going to pick that update text there from the static list. Now, we don't need to send a parameter from the parameter list because essentially every time that we get an on value changed, we want to call or just essentially tickle that that function, and then it will go and find the value of the slider from the slider reference that we've made on the script. So let's go ahead and save that, and let's go ahead and enter play mode, and then we can see that essentially it has the same functionality. But the main reason I wanted to show you that was that if there is some reason that you can't send the parameter that you want, you can still make your references, and that those functions will be called every time that on value changed list is called, or whatever the event list is that's attached to that particular element. This is also true the way that we've hooked up this text field that we have up here. Will work also the same way for hooking up a text field to, say, for score or for a timer. We can have that script in our game that has a score, has an update score with a reference to that text element, and then sends that value, and every time there's a new score, updates the score in your game manager, and the game manager with a reference to that text goes ahead and updates the text on the score text that's there in your game. On value changed lists are going to be the same with a toggle. So we can see that in this case, for the sort of temp panel that we have set up, that the on value changed list is empty, but you would create a toggle there that would go ahead and send the value. So let's go ahead and exit play mode, and then take a look at this toggle. We've got our 3D sound toggle there, and our list is empty. So let's go ahead and add a list, and then we can grab our main camera, and then we can see that under the function list there is the camera, and then we have a dynamic bool. So then we could say the orthographic value is now attached to our dynamic bool. So let's go ahead and save this, and we can enter play mode, and we're dealing with a 3D sound toggle. We've now tied that into the camera. We can see as we toggle this, it's toggling that camera between orthographic and not orthographic. I'm going to go ahead and remove that. So quickly, I'm going to show another set of UI elements that I think work really well together. I'm going to go ahead and make a scroll rect, and then I'm going to attach a scroll bar to it. So in our panel, and note this is that if we do our context click, our right click, we can now make a UI object, and then we can say, let's make another panel. And we can see that by right clicking and having had the panel selected, that new panel has come in as a child. So let's call this, actually I didn't want it there, so I'm going to undo that. I'm going to just make that a child of the canvas. But you can see now that I do that UI panel, it's now a child of the canvas, whereas when I selected the panel, it was a child of the panel. So I'm going to back out and take a look at all of this. It's a bit big. When you make a panel like this, it stretches it to match that of the parent. I want it to be smaller, and I'm going to grab the anchor handle and hold down the shift key. And whoa, no, not that. I'm going to grab the anchor handle and hold down the shift key, and I'm just going to move this over and up a little bit. I'm going to sort of replace this location of where this panel is. I'm going to turn off this the canvas there. So this is just going to be my simple panel. Let's go ahead and grab a graphic for that. So that's an image. It's just got the background image. Let's go ahead and pick something a little bit more interesting. SF panel. That's what we were using before. And then let's go ahead and I want to make a scroll rect for this so we can scroll something in it. Part of what I think the panel's a bit dark because our alpha is low. So let's pump up the alpha a little bit on that. Bring that up a little bit stronger. And then I'm going to create a new game object. I want it to be the child of the panel. So right click on the panel and then make an empty child. And let's call this scroll view. And what I want to add to that is I want to add a scroll rect. And the scroll rect is a container. It's going to be able to hold other objects inside it, other objects that are larger than it. And if we use a mask, we can mask it inside to the size of the scroll rect, and then we can scroll things around. So let's go ahead and again, I'm going to stretch this out. So it comes more close to the let's frame selected on that and bring that around. So a little bit bigger. So there's it's going to be our scroll rect, something like that. And then let's find a big image. There's a big image in here that I used for the Well, no, let's make text. How about that? Let's do some scrolling text. So let's make a text child. So again, click on the object. Let's go ahead and make a UI text. And then let's go ahead and stretch this out so it's much larger than the parent. Way big like that. And then I'm going to go ahead and grab some text from another location. And I'm going to go ahead and just sort of paste in that text. So now we can see that the text doesn't quite fill it. So let's grab one more paragraph and paste it again. There we go, nice and full. So we now have this huge amount of text. Now it sticks out beyond the bottom of our scroll rect. We now need to assign the text as the content. So let's go ahead and save and play. We've just simply made that content as a text child, and now we can see it's completely scrollable. Ready to go. It's only scrolling on one axis, up and down, even though we've got horizontal and vertical, because it is not wider than the scroll rect. So if the parent scroll rect, sees that something is not wider than its own rect, it's not going to scroll in that direction. So it's only scrolling up and down. But two things I want to do. One is I want to mask it inside the scroll rect, and the other is I want to add a scroll bar. So to mask it inside the scroll rect, let's go ahead and add. First thing we want to add is an image. The image is going to be used by the mask to create its mask, and so then the next thing we want to have is a mask property, and so we can choose to show the graphic or not as a background. So let's turn that off. Automatically uses the image for the mask, and we can see that it's clipped. And if we hit play now, we can see that that's scrolling behind the mask. Now, I want a scroll bar. Now, attaching a scroll bar to this is super easy. So again, click on the panel that we want this to be a child, and to be a child next to it, or we can make it a child of the scroll view. Either way doesn't really make that much of a difference. Go ahead and do our context click, make a UI scroll bar, and there's our scroll bar. Now, that's default is a horizontal scroll bar, and I want it to be vertical. So I'm going to go ahead and change this to 20, roughly. Oops, try that again, not 200, 20 please. And then let's, what do we figure, about 200? We can stretch that out as we need to. Let me frame select it in on there. And then pump it up. As a child, of course, it's going to be masked with the parent, so we don't want that to be there. We want that to be up on the parent there, so we don't mask it. We put that on the side. And then let's just go ahead and stretch that down, zoom out a little bit. Stretch that down to the match, and we can see that it's snapping. And then scroll view has got horizontal and vertical scroll bars as optional. You don't have to have them, but we can simply grab our scroll bar, put it there as the vertical scroll bar, save. Okay. So before we hit play, let's go ahead and change the direction. Our direction choice is left to right, right to left, bottom to top, and top to bottom. So let's go ahead and do bottom to top. Let's hit save. Let's go ahead and hit play. And now we can see that scroll bar is automatically working. Now, if we were to change this to top to bottom, we can see that it reverses the order in which it works. So it depends upon how you want to do this. Changes the direction in which case the scrolling. Now, I prefer the bottom to top, which is more traditional for me, but you can choose. You can decide to do it any way you want to. But you can see how quickly that was to hook up. We now have scrolling text in a box. Very fast, very useful, fantastic. Well, we're running out of time, so I'm going to have to wrap this up. There's still a ton of more things to show, and this is sort of a quick down and dirty overview. We're going to present some more of these, and we're going to go into these in detail. I do want you to look at the lessons on the Learn site and take a look at what we have there. But one last thing that I think is very important to note, which is render order. It's something that we haven't talked about. How does the canvas order its render layers? You can order canvases if they're in the world space using sorting order and order and layer. But within the canvas, render order is created directly by the order that the objects are in the hierarchy. So I'm going to go ahead and turn off the new panel that we've created. So that's this one down here. So let's just turn that one off because I just don't want to distract us from what we're doing, and take a look at the panel that we have now. We have our panel. Right now there's only one thing in here. So let's move actually. Let's go ahead and move the back button out. And let's go ahead and move the accept button out. So these are now no longer part of the panel. And notice that when I moved them out, it moved them to the bottom. Now let's see what happens when we move this above the panel. You can see that now the panel is being rendered on top of the back and accept buttons. That's because the UI elements are rendered from back to front, top to bottom. So the very first things in the list, reading top down, are rendered first. So we can see that the accept button and the back button are behind the panel. If we were to move these over, we can see that the accept button is behind the back button. I can reorder them, and we can see that the order changes down here as well. We can see which ones are coming front to back and which ones are coming back to front. And that all has to do with the render order, has to do with the order in the hierarchy. That's a quick overview, really down and dirty. I'm glad you came. I'm glad you saw it. There will be more. We'll present more of these in depth. We're going to start showing some examples as well. But definitely do head on over to LearnSite, take a look at the new UI section, and take a look at the new and growing set of lessons that we have posted there. And thanks for coming. And we're glad, like I said, we're glad to have you, and we're glad that you were here for this special session of Unity's live training. So go ahead and follow us. Follow us at Will Goldstone. Follow us at Mike Geig. Follow us at the Ant Ranch. Anyway, thanks for coming, and I'll talk to you later.